There are discoveries that expand our understanding of the universe. There are discoveries that force scientists to revise old ideas. And then there are discoveries so unexpected that they raise entirely new questions about how the cosmos works. The James Webb Space Telescope may have delivered exactly that kind of moment. Since its launch, Webb has transformed astronomy by allowing humanity to see farther into space than ever before. Because light takes time to travel, looking deeper into space also means looking further back in time. Every distant object captured by Webb is a glimpse into the ancient history of the universe, revealing what existed billions of years ago. Astronomers expected these observations to confirm many aspects of our current understanding of cosmic evolution. According to modern cosmology, the universe began in a hot, dense state roughly 13.8 billion years ago. Over hundreds of millions of years, gravity slowly gathered matter into stars, galaxies, and eventually the large-scale structures we observe today. The earliest galaxies were expected to be small, faint, and relatively simple. Scientists imagined they would resemble cosmic building sites, still assembling themselves from clouds of gas and newly formed stars. But when Webb began peering into the deepest reaches of the cosmos, it encountered something surprising. Instead of finding only tiny, immature galaxies, researchers discovered numerous objects that appeared unexpectedly bright, unexpectedly massive, and unexpectedly mature. Some of these galaxies seem to have existed when the universe was less than 1 billion years old. Yet they contain enormous numbers of stars and appear far more developed than many models predicted. The discovery immediately sparked excitement across the astronomical community. At first, many researchers suspected the observations might be misleading. Distance measurements in astronomy are incredibly challenging. Light from distant objects is stretched by the expansion of the universe, creating what scientists call redshift. If an object's redshift is misinterpreted, its distance and age estimates can also be wrong. But as additional observations arrived, many of these galaxies continued to appear unusually large and bright. The mystery deepened. These weren't isolated examples. Webb was finding multiple candidates across different regions of the sky. Each discovery seemed to tell the same story. The young universe may have been far more active than expected. To understand why this matters, imagine constructing a city. If someone told you a small village existed a few years ago, you would not expect to find a skyline filled with skyscrapers today. Large structures take time to build. Astronomers had a similar expectation for galaxies. Massive galaxies require enormous amounts of matter, countless generations of stars, and long periods of growth. Yet some of Webb's observations suggest that substantial cosmic structures may have formed remarkably quickly. This raises an important question. Did galaxies grow faster in the early universe than current theories predict? Or is there something about galaxy formation that scientists have not yet fully understood? Researchers around the world are working to answer these questions. One possibility is that stars formed with much greater efficiency in the early universe. Under this scenario, gas clouds could have converted into stars at extraordinary rates, allowing galaxies to grow rapidly during their first few 100 million years. Another possibility involves dark matter. Although dark matter remains invisible, scientists believe it makes up most of the universe's matter content. Its gravitational influence helps shape galaxies and large cosmic structures. If dark matter behaved differently during the universe's earliest eras, it could potentially explain why galaxies appear to have developed faster than expected. Others suggest that entirely new physical processes may have influenced the formation of the first galaxies. At the moment, no single explanation has gained universal acceptance. That uncertainty is what makes these discoveries so exciting. The James Webb Space Telescope is not simply collecting beautiful images. It is gathering evidence that allows scientists to test some of the most important theories in modern cosmology. And galaxies are only part of the story. Webb has also detected evidence suggesting that supermassive black holes may have appeared much earlier than previously thought. These cosmic giants can contain millions or even billions of times the mass of the Sun. In today's universe, supermassive black holes are commonly found at the centers of large galaxies. Scientists believe they grow gradually over time by consuming matter and merging with other black holes. But Webb has identified candidates that seem to have reached enormous sizes surprisingly early in cosmic history. This creates another mystery. How did these black holes become so massive so quickly? Did they begin as unusually large seeds? Did they grow at extraordinary rates? Or are scientists missing an important piece of the puzzle? Every new observation seems to generate additional questions. Far from being frustrating, this is exactly how scientific progress works. Major discoveries often begin with unexpected results. Throughout history, many of the greatest breakthroughs emerged when observations failed to match existing predictions. The discovery of expanding galaxies changed our understanding of the universe. The discovery of quasars revealed entirely new cosmic phenomena. The discovery of dark energy transformed modern cosmology. Today, Webb may be contributing another chapter to that tradition. Its observations are forcing researchers to examine assumptions that have guided astronomy for decades. Importantly, none of this means established science has been overturned. The Big Bang model remains supported by extensive evidence, including the cosmic microwave background, the expansion of the universe, and the observed abundance of light elements. However, the details of how galaxies and black holes formed in the earliest cosmic eras may require significant refinement. Science does not advance by proving everything wrong. It advances by improving explanations when new evidence becomes available. That process is unfolding right now. Every month, astronomers publish new studies analyzing Webb's observations. Teams around the world compare models, test hypotheses, and search for explanations that fit the data. Some mysteries may eventually disappear as better measurements become available. Others may lead to entirely new discoveries. The most exciting possibility is that Webb is revealing aspects of cosmic history that have remained hidden until now. For decades, humanity could only speculate about what the earliest galaxies looked like. Today, we are beginning to see them directly. These ancient objects are more than distant points of light. They are messages from a time when the universe was young. Each galaxy, each black hole, and each faint infrared signal carries information about events that occurred billions of years before Earth even existed. The deeper Webb looks, the more detailed that story becomes. And with every new observation, astronomers move closer to answering some of humanity's oldest questions. How did the first galaxies form? How did cosmic structures emerge from the aftermath of the Big Bang? And why does the universe look the way it does today? The answers have not yet been fully revealed. But one thing is clear. The James Webb Space Telescope has opened a new window into the universe, and what lies beyond that window is proving more surprising, more complex, and more fascinating than anyone expected. The coming years may bring discoveries that reshape our understanding of cosmic history. For now, the universe is offering us clues. And Webb is helping humanity read them for the very first time.